Welcome to the final exam review part 7 for pre-calculus. Any that you see on here are kind of crossed off. We haven't learned those yet, and like I said on the final, just do your best, take a guess, and I will curve it based on, I'll only grade it on things that we've learned in class, obviously. Okay, number 42. For the right triangle below, find the value of x to the nearest hundredth. So identify your right angle and the angle you're working with, and label from here. Across from your right angle, not across from your right angle, excuse me, across from the angle that you're working with is your opposite. Across from your right angle is your hypotenuse, and what's left is your adjacent. Don't skip this step. A lot of people do, and that's where they mess up. Okay, and if you use our little saying, so, ka, toa, and if you look, I know the hypotenuse and I want to know the adjacent. So what uses adjacent and hypotenuse? The cosine. So I set up my trig function. The cosine of my angle, which is 63 degrees, equals the cosine is the adjacent, so x, over the hypotenuse, which is 16. I want to get x alone. It's being divided, so I'm going to multiply each side by 16. This is going to get cut off there, sorry. I'm going to multiply each side by 16. On the right, the 16s cancel. And I'm going to do this on my calculator, but I'm going to be very careful and check that my calculator is in degrees first. So 16 times the cosine of 63 degrees is 7.26. 7.26 equals x. Okay? Skipping 43, and let's move on to 44. 44 says an angle of 5 pi over 6 will terminate in which quadrant? So let's think of just those key quadrants. In radians, it's 0, pi over 2, also known as 0.5 pi, pi, and then 3 pi over 2, which is 1.5 pi, and we circle back around. One full rotation is 2 pi. So there's several ways to do this. I'm just going to, off the top of my head, say 5 over 6 is smaller than 1. So it's not going to go past 1 pi. So quadrants 3 and 4 are out. Okay? So if you do 5 divided by 6 in your calculator, you come up with 0.83. So I did 5 divided by 6 gives me 0.83 pi. Remember, pi over 2 is like 0.5 pi. So I definitely have to go past that. Am I going to go past 1 pi? No, I'm going to land someplace over here in quadrant number 2. If you need to write this down, please pause the video as I am moving on. We did not cover 45. 46. A flagpole cast a 15-foot shadow. Immediately, you need to draw a picture. Don't laugh at my drawing skills. Here's my little flag. Okay? It cast a 15-foot shadow. Think about where your shadow is. Okay? It's on the ground. So they're saying this is 15 feet. The angle of elevation from the end of the shadow to the top of the pole is 35 degrees. So the angle of elevation or depression always is formed with this horizontal line. So I know this has to be 35 degrees right here. What is the height of the pole? The flagpole is over here, and I want to know how tall it is. So again, circle the angle you're working with and label your sides. Across from the angle that you're working with is your opposite. Across from the right angle is your hypotenuse, and the one that's left is your adjacent. And always writing down so, ka, toa. Remember how to spell it. Okay, I want to know the opposite, and I have the adjacent. So what uses O and A? Tangent. So I'm going to write out the tangent of my angle, which happens to be 35 degrees, equals my opposite x over my adjacent 15. I want to get x alone. When x is on the bottom, you multiply by 15. Or I have the little saying, when x is up high, you multiply, right? These 15s cancel, and again, making sure your calculator is in degrees. You don't have to do it every time, but the first time you use it for the day, you should. I get 10.50 equals x. I am going to erase this so I can do 47, so please pause it if you need to write this down. Okay, so let's go ahead and do number 47. 47 says, you are on a ship that is 950 feet from a lighthouse. So I'm just going to write ship, and I'm going to call it LH for lighthouse. If I'm 950 feet, that's straight across. If the lighthouse is 76 feet tall, what is the angle of elevation to your lighthouse? Okay, so remember I told you the angle of elevation or depression always has to go with this horizontal line. So I'm looking for this angle right here because that's with the horizontal. I know it doesn't look like elevation, it's just the way I drew it. It will be the same as long as you make sure it's with the horizontal line. So I identify what angle that I want to work with. Okay, I'm going to work with this one because I want to know it, and let's label. Across from this angle is your opposite. Across from the right angle is your hypotenuse, and what's left is your adjacent. So I know my opposite and I know my adjacent. So what uses opposite and adjacent? Tangent again. So set it up. The tangent of your angle, you don't know it, so we'll call it x, is opposite 76 over adjacent, which is 950. When you're looking for the angle, you use the inverse tangent. In your calculator, that's second tan. And you take it of the tangent ratio, and that's what will equal x. So in my calculator, I am typing tangent inverse of 76 over 950, and you come up with 4.57 degrees. 4.57 degrees equals x. Again, if you need to write this down, please pause it as I am moving on. 49. For the right triangle below, find the secant of A. Now, we know we have sine, cosine, and tangent, but we also learned about 3 new trig functions this year called secant, cosecant, and cotangent. Cotangent is the easiest one to match up because it's the flip of tangent. Now, secant and cosecant, I used to get confused, but here's how I think of it. Secant, I'm just going to write it up top here, starts with S. It can't go with one that matches the same letter up front. So it doesn't go with sine. It has to be the flip of the cosine, and that means the other one, the cosecant, is the flip of sine. So since I'm looking for the secant of A, first I'm going to find the cosine, and then I'll simply flip it over. So let's look at our triangle. They tell me right here I have to use angle A. So circle that. Across from your angle is the opposite. Across from the right angle is your hypotenuse, and what's left is the adjacent. Now I want the cosine first. So if I write out my little saying, so katoa, cosine is A over H. So the cosine of angle A is A, my adjacent, 5 over my hypotenuse, which is x. So the secant would simply be the flip of this. It would be, the secant of A would be x over 5. They may want you to solve for x. I'm going to erase some of this up here, so if you need to write it down. If it's a multiple choice test, so if they actually gave you numbers, where would they get a number from? Well, I can find any missing side in a right triangle if I know the other two sides using a squared plus b squared equals c squared. You could have done this first. C has to be your hypotenuse, and it doesn't matter where you put a and b. So 5 squared plus 12 squared. 25 plus 144 equals x squared. I'm going to come right up here. That's 169 equals x squared. And you take the square root of each side to get rid of that square. And 13 equals x. So they may have x over 5, but I have a feeling they're going to replace x with 13. So the cosine would have been 5 over 13, which makes the secant 13 over 5. I am going to erase this so I can work on 50 right above this. Please pause it if you need to write it down. Number 50 says, James throws a ball from the balcony to the ground below. The flight path follows this formula, where h is the height of the ball in feet and t is the time in seconds. What is the maximum height the ball will reach? Hopefully you recognize this is a quadratic equation, and I know it's quadratic because it's the highest power is 2 or squared. Okay, so they want the maximum height. Well, the maximum or minimum always occurs at my vertex. Okay, and I can confirm this opens downward because my leading coefficient is negative, which indeed tells me my vertex will be the maximum. The formula for the vertex of a quadratic is the opposite of b over 2a. The a value comes from the number in front of your squared term. Then we're also going to go ahead and look for the b value, which is just in front of your x, or just in our term t value. So if I plug these in, the opposite of 80 is negative 80 over 2 times negative 16. Okay, so 2 times negative 16 is negative 32. So when I do that, negative 80 divided by negative 32 is going to give me 2.5. Okay, 2.5. I called it x. Really, I shouldn't have. They use the variable t. So t is your time. It tells me right here, t is time. But they said, what is the maximum height? Height is h of t. So to find that, I'm going to plug in 2.5 for t. So I have to find h of 2.5. All I'm going to do is replace every t value with a 2.5. Plus 300, I'm going to run out of room here. So when I do this in my calculator, negative 16 times 2.5 squared, I forgot to write that. It should be squared. Okay. Plus 80 times 2.5 plus 300, you end up with 400. That's how high the ball got. And it's in feet because it says the height of the ball in feet. So 400 is how high the ball gets. That will be the end of this video. We'll have one more and be done.